company estimates the price-demand equation for its widgets to be P equals 700 minus 0.08x, where P is the price and X is the quantity sold. The company is currently selling its widgets for $315. So what should the company do to increase revenues? Increase prices, decrease prices, or maybe it can't increase revenues. So we're going to look at this. We're going to use calculus. So to solve this, what we need to do is to think about our revenue equation. So revenue as a function of price is price times quantity. Now, of course, this quantity is a problem for us. We need to get rid of that and turn quantity into a function of price. Now, again, we have price as a function of quantity. We need to rearrange our function so that we can have quantity as a function of price and substitute. We're then going to take the derivative and we're going to plug in 315 to decide what's going on. Now, if the derivative is positive, that means increasing prices will increase revenues. If the derivative is negative, that means increasing prices is going to decrease revenues, which means, of course, we want to decrease prices, which will then increase revenues. So let's look at this. So let's first do a little bit of work. We're going to rearrange our equation here. We have P equals 700 minus 0.08x. Let's rearrange. We have 0.08x equals 700 minus P. We're going to divide both sides by 0.08 and get x equals 700 divided by 0.08 minus P divided by 0.08. Now, I don't really like this 0.08 in the denominator, so I'm going to pull out my calculator. Let's calculate 700 divided by 0.08, which gives us 8,750. So that's 8,750 minus, and then we just do 1 divided by 0.08, and we get 12.5. So minus 12.5p. Okay, so now we have our equation. X is a function of P. So now we can go over to our revenue and we could substitute, instead of having an X here, we're going to substitute in this 8750 minus 12.5p. So our revenue equation becomes P times 8750 minus 12.5p. Okay, let's simplify a little bit. Multiply things out, and we get 8750p minus 12.5p squared. Okay, remember now we're going to take the derivative. We can take the derivative using the power rule and a couple other differentiation rules, simple differentiation rules. We do it term by term. And so we take our derivative, r prime of p equals 8750 p to the 0, so that's just 8750, minus, we're bringing the 2 down, 2 times 12.5 is 25, so that's minus 25p. Okay, so that's our derivative. We want to calculate r prime of our current price, 315, equals 8750 minus 25 times 315. Again, let me pull my calculator out here. So 8750 minus 25 times 315 gives me 875. So 875. So let's interpret. First off, this is positive, which means that increasing prices will increase revenue. So the company should increase prices to increase revenue. Now, approximately, this isn't exact, but approximately, if we increase the price by 1, so 315 to 316, we would expect revenues to increase by about $875. So that's an interpretation of what the derivative means. That's not an exact calculation. It's an approximation of how much will change. If we increased by $2, 315 to 317, we would expect that approximately revenues will increase by 875 times 2. Again, the larger the price increase, the less accurate this approximation is going to be. So we have to be a little bit careful extrapolating what's happening here, increasing prices, increase revenue, with very significant price increases, probably doesn't tell us that.